Hello, my name is Minyoung Nam, and this is the second demonstration for our tool called ASIIST. And this time we're going to be showing the bus delay analysis capability of our tool. As before, we're going to be loading in the model on the left and then run the ASIIST tool. This time we're going to select the bus and delay analysis and load in the model. This time the table is going to have a list of all the connections that exist in the model. Extending the connections, you can see the hardware flows that exist in the system due to that logical connection. We're going to be running the analysis. When the analysis is finished, it's going to update the delay parameters for each connections, and also a deadline percentage if there's a deadline for that connection. Now we're going to move to showing the graphical view for the bus delay analysis. So as before, we push the visual graph view button on the right. And then what you will have is a graphical view of the hardware platform and also the hardware flows that exist on the platform. Now, it doesn't show all the connections because we try to filter out the connections that are only problematic. So it only shows the red one that has a deadline capacity of more than 90. You can change the capacity to show more flows. Also, you can select a subset of flows to only show on the right side table. And by selecting a partition on the hardware platform, you can limit to see only the connections that exist in a partition or even that go through a certain hardware component. Now we're going to make it back to 90%. And you can see that the flows for the style application is problematic at the moment. And then changing the coloring scheme, you can identify the connections more easily. When you put your mouse on top of any connections, there's a pop-up information about the connection. Also, right-clicking it, you'll see a menu where you can select to find that connection or hardware flow inside the table. Also, if you right-click it, there's also a button for the editor so that you can edit the connection that you've just selected. The specification of the hardware flow consists of a list of hardware components. So this editor helps you in building that list of hardware components. So it's going to provide the next candidate hardware component. So it's much easier to build the hardware list. You can see other connections and check out their hardware flow information. Now, connections that doesn't have a hardware flow specification, you can also right-click on it and then click on the add so that you can add the hardware flow specification if it's missing. Now, next we're going to be showing the demo for cache interference. When hardware flows from peripherals access the front side bus, it's going to interfere with the cache fetch of an application from the processor. So this is going to eventually increase the execution time of that application, and we capture that effect. So currently, from the Schedulability Analysis tab, all the applications are schedulable for each partition. Now, if you pay attention to the execution time, when we run the cache interference analysis, it's going to increase. And then the partition some partition can become unschedulable. So we increase the partition size for that partition, and then we run the schedulability analysis to make it schedulable. So when applications are moved among processors or partitions, the hardware flow specification needs to be modified. So our tool also does that for you so that you won't have to do it manually. So right now we drag and move the stall warning application to a different processor. Obviously, if the stall warning application is moved, it becomes more schedulable because the other one was empty. And if you look at the graphical view, you can notice that all the connections that are related with the stall warning has been moved to the processor on the right. And it's gray color because the analysis needs to be redone. So we're going to load in the hardware flows once again and then redo the delay analysis because the model has been changed. Now, we can predict that when the analysis is finished, the stall warning connections are now no longer problematic because it basically was moved to a processor that was empty in this model. And you can see that all the stall warnings are now bright green. Also, our tool updates the ADL file for us. So before, the connections for the stall warning was saying CPU 2, and we've just moved it to CPU 1. So if we generate the text file from the meta file, you'll see that it updated all the connections so that it goes through CPU 1, which was the second processor where we drag and drop to. All the other connections exist in a CPU 2. And that concludes our demo for the ASIIST for bus delay analysis. Thank you very much for watching.